Okay, once again, good afternoon to all of you. So today is the continuation of the previous class. Actually, in the previous class, I taught you about linear differential equation and Bernoulli's, how to deal with the Bernoulli's equation, how to deal with the linear equation. So in this today, we'll talk about some integrating factors, rules for determining the integrating factors, right? So first I will talk about rule 1. So rule 1, if mdx plus ndy equal to 0, you know that this is the first order first degree differential equation that can be written as most simple form of the first order first degree equation. Mdx plus ndy equal to 0 is both homogeneous and exact, and you know that conditions for exactness is del m del y. And you know that condition of exactness is del m del y equal to del n del x. That is the condition of exactness. Okay, so if your equation is both homogeneous and exact, then its primitive is mx plus ny equal to c, provided that the degree of homogeneity is not equal to -1. So this is one of the special case of rule 1. Now this one is important. Number 2, if mdx plus ndy equal to 0 is homogeneous but not exact, so it will not follow del m del y equal to del n del x. And if mx plus ny not equal to 0, then 1 by mx plus ny is an integrating factor of the equation. So let's have a problem on that. So what was the conclusion? That if your first order first degree equation is homogeneous but not exact, then, and if with addition of that mx plus ny not equal to 0, then 1 by mx plus ny is an integrating factor of the equation. Okay, so let's solve. We have x square plus x square y dx minus x cube plus y cube into dy. So here your m is x square y m dx and n is minus x cube y cube, minus of x cube plus y cube. So you can easily check that del m del y is not equal to del n del x in this case, because it is not exact. So it is not exact. You can check that your del m del y is, what is your del m del y? Del m del y is x square, and what is your del n del x? Your del n del x is minus 3x square, right? Minus 3x square. So that is not equal to so this is not exact, but it is homogeneous. You look at that by identification. The power is 3 altogether, and each power, if all the degrees are equal actually. So this is a homogeneous, and you check that mx plus ny. So you write now mx plus ny equal to, what is your mx? Mx will be x cube y and plus ny, so minus x cube y minus y to the power 4. So this get cancelled, so you have minus y to the power 4, and that is not equal to 0, right? So 1 by mx plus ny is an integrating factor of this equation. So you write 1 by minus 1 by y to the power 4 is an integrating factor of the differential equation, right? So what you will do with this integrating factor, you will multiply the whole equation with this integrating factor. So multiplying, okay, and rearranging, multiplying and rearranging, you will get x square by y square into y dx minus x dy by y square plus 1 by y dy equal to 0. This is after simplification. So you are multiplying the whole equation by minus 1 by y to the power 4. So look at that, your first term will be x square by y cube, okay, and and the next one will be minus x cube plus y cube by y to the power 4. So that will be, and the last term will be this one. And if you arrange these two, open the bracket and arrange, and after some calculation, this will be the result. Okay, and you know that this will be your form of minus x square y square into d of x by y, because y square is an 1 by y square is an integrating factor of this expression. You have learned that. So it will result in x by y, d of x by y plus 1 by y dy. So now you can integrate that. Integrating, you will get the result. Okay, integrating, you will get this is like x square dx. What is the answer of x square dx? Minus x cube by 3y cube, right? Plus log y ln y equal to c. So this is the answer. This is the general solution of this differential equation. So look at that. We have applied rule 1, that m dx plus n dy is homogeneous but not exact, and if this is not equal to 0, then this is an integrating factor. With the help of an example, we have explained the thing. Let's move to rule 2. Next rule is rule 2. If 1 by n del m del y minus del n del x is a function of x alone, fxa, then e to the power integration fx dx is an integrating factor of m dx plus n dy equal to 0. So you have a expression, this 1 by n, this is the testing. Suppose you will go for rule 1. If rule 1 is not satisfied, you will go to rule 2. You will check for rule 2. How will you check? You will check del m del y minus del n del x 1 by n. If this is a function of x alone, it's fine. E to the power integration fx dx is an integrating factor, okay, of this first order first degree differential equation. The proof of this statement, actually this rule 2 is very simple. Suppose let me give you hint for how to prove that. Suppose 1 by n del m del y minus del n del x equal to fx. This is your assumption, okay? Then hence del m del y can be written as del n del x plus n into fx, right? This goes to that side, cross multiplication, and after that. Now this is the equation. Now multiplying by the integrating factor that you was talking about, e to the power integration fx dx. So multiplying this last equation by that integrating factor. So what I am doing, I am multiplying, right? Multiplying by the integrating factor, okay? Multiplying by the integrating factor, what you have, e to the power integration fx dx del m del y throughout, I am multiplying throughout, e to the power integration fx dx into del n del x, right, plus n fx e to the power integration fx dx. So I am multiplying throughout the equation with this integrating factor, and you look at that, this can be written as del del y of m into e to the power integration fx dx, okay? because you are differentiating partially with respect to y, and m is a function of xy, but this is a function of x, so it will constant, so you can write this directly. And on the right hand side you can write, you may write del x of n e to the power integration fx dx. Okay, because you see, you can apply partially with respect to x, you are differentiating, n is a function of x and y, also exponential function is a function of x, so uv, you apply uv n fixed partial derivative with respect to x of exponential function, that will give you this one, and n is e to the exponential function is fixed, and you are differentiating n with respect to, that will give you del. So combined, you can write the right hand side in a combined form of this. Okay, and this shows that you can write, let me write a differential symbol for, we can write m dashed, suppose m dashed equal to m e to the power fx dx, and n dashed equal to n e to the power integration fx dx, right? So what do you have now? You have a very simple thing, that is del y of m dashed equal to del x of n dashed. So that is the condition of exactness, and we see that your equation, that is m dashed dx plus n dashed dy is exact, equal to 0, is exact from this, right? Okay, since del m dashed del y equal to del n dash del x, sorry, I have made a mistake here, it will be x. Okay, so that's the thing, it's a exact. Okay, so that is, what is your m dashed, you can substitute that and see that m dx plus n dy into e to the power integration fx dx, just changing m dashed n dashed, replacing the values of m dashed and n dashed in the equation, fx dx equal to 0, satisfies the condition of exactness, satisfies the condition of exactness. You may write in the last line, satisfies the condition of exactness, right? So this is the thing. So we prove that e to the power integration fx dx is an integrating factor of this m dx plus n dy equal to 0 of this equation. Okay, so this is the proof, very simple proof. Now let us have some application on that. Let us apply in our problem. So you have a problem, solve 2x square plus y dx plus x square y minus x dy, and look at that, your m is 2x square y and n is x square y minus x, and you can easily check that by inspection, this is not homogeneous, and you can verify, you can check for exactness also. Whatever you know, whatever you have learned, you can check that first before going into the rule 2. First you apply rule 1, before that you have to test for homogeneity, separation, all the things, linear, Bernoulli. If all the things are failed, you go for check for rule 2, del m del y. What is your del m del y? Del m del y will be 1, and what is your del n del x? Del n del x will be 2xy minus 1, right? Now you can check that what is your del m del y minus del n del x. You can apply this formula, rule del m del y minus del n del x, that will be simply 2xy. Okay, and what is your n? Okay, let us apply 1 by n. Let us apply this rule. Let us first calculate that whether it is a function of x alone or not. So del m 1 by n del m del y minus del n del x. Let us calculate that. So it will be 1 minus 2xy plus 1, okay, because minus minus plus, by x square y minus x. And you see that it will be 2, and if you take common, so it will be minus 2 by x only, because xy minus 1, in the numerator also you have xy minus 1 if you take minus common. So this is a function of x alone, so you can apply rule 2. So what is your integrating factor? What is your integrating factor? Your integrating factor is nothing but e to the power minus 2 by x dx. So that is equal to 1 by x square, because it will be log x, and log of 1 by x square, e to the power log of x 1 by x square is simply 1 by x square. You know that. So this is how, if it is a function of x alone, e to the power integration fx dx is an integrating factor. So that you have applied. Now you got the integrating factor for this differential equation. What you will do with this integrating factor? You will just multiply the equation with this integrating factor. So you have to write that statement here, that multiplying with this integrating factor, what we have, you are multiplying with 1 by x square. Look at that. You have 2 plus y by x square into dx plus y minus 1 by x into dy. You are multiplying throughout. Look at the first term. If you multiply by 1 by x square, it will be x square gone, okay. And if you multiply y by it will be, second term will be y by x square, that is the first product, and next one will be y minus 1 by x. So that you have, okay. Now you do the integration. It is a simple integration, and you have to take pair of this. So you take 2 dx plus y dy inside a bracket. This is easily integrable. And next pair this one, y by x square dx minus 1 by x dy equal to 0, and that will give you, if you integrate, so it is, okay, let me write the second term. Second term can be written as d of minus y by x, right? D of minus y by x. You check that. So if you integrating, you have 2x plus y square by 2 minus y by x equal to c. So this is the answer, okay. This is the answer. Let me write properly, otherwise you will mess up with this. 2x plus y square by 2 minus y by x is equal to c, okay. This is the, so after that multiplication you can easily handle the equation, and you can check that this is the solution of that equation. Let's move to now rule 3. That is, we have talked about rule 1 and rule 2. Rule 3 is very similar to the previous one, just you are replacing n by m. So in this case you have 1 by m del y minus del n del x. The same expression is a function of y alone, phi y, then e to the power minus phi y dy is an integrating factor. Here you have a minus here, be careful about that. So you have the same expression, okay, this one, and you have a 1 by m, and this e to the power minus phi y dy is an integrating factor of m dx plus n dy equal to 0. So I am not going into proof of that. Proof is similar to previous one. You can check that proof. Proof of this theorem is very easy, because you can take a help of the previous proof. Just I have proved like that, assuming this, you can check. And let's have the problem application of that rule. So you will test for rule 1. you will test for rule 2. Next you will you will check rule 3. Next come to rule 3. So here m is this one and n is this. So let us apply del m del y. Let us calculate del m del y first. So your del m del y is 12 x square y cube plus 2x, because with respect to y, and your del n del y. In every problem you have to calculate del m del y minus del n del x, del n del x in every problem. So you can check that. In that way you can check that first you check that the exactness, whether it is exact or not. So del n del x, what is your del n del x? Del n del x is 6x square y cube minus 2x. So it is not exact, it is not homogeneous. Okay, so let us now subtract del m del y minus del n del x. What is that? You check. That is del m del y minus del n del x, that is equal to 2 into 3x square y cube plus 2x. You check that. That will be the result if you take 2 common. So that is similar to your m. If you take del m del y minus, okay, let's take a multiplying 1 by m. Whether you can use it for n also. First you check for n. If it is not a function of x, you check for m if it is a function of y or not. So what is your m? M is 3x square y to the power 4 plus 2xy. So if you take y common, so that will be 3x square y cube plus 2x. So you can check whether m, if you substitute m, it will be get cancelled or not. You can check for n also. So you can easily check, verify that by your observation only. So this get cancelled, right? So you have 2 by y, and it is completely a function of y. It is a function of y only. Function of y you can write here. Okay, so what is your integrating factor, my dear students? Your integrating factor is e to the power minus 2 by y dy, 2 by y dy, and that is equal to 1 by y square. You can easily integrate and check. So what you will do with this integrating factor, you will multiply the equation, whole equation throughout by this integrating factor. So let us multiply the equation. I am not, again you have to write that statement multiplying the equation by this integrating factor. So you have, after this multiplication, 1 by y square into 3x square y to the power 4 plus 2xy dx, okay, plus 1 by y square into 2x cube y cube, 2x cube y cube minus x square dy equal to 0. Okay, so now you have to do the pair up. Okay, now you look at the first term. First term is, if you divide by y square, it will be 3x square y square, right? And you check here in the first term, if you multiply, and this is dx, right? This is dx. And if you here you come to the second term, if you multiply with 1 by y square, that will be 2x cube y. Got it? 2x cube y dy. So this will be together because that will produce the same result, and the rest of the part will be 2xy dx minus x square dy by y square. Okay, now you look at that, you have learned that how to write this. You can write this as a total differential, that is d of u in the form of, and that is equal to d of x cube y square, and the second one will be d of x square by y. So you can easily check that one. So if you integrating, you will get x cube y square plus x square by y equal to c. So that is how you will apply rule 3, sorry, So rule 2 and rule 3 are very similar. You can check that for m, if it is a function of y, apply your integrating factor e to the power minus phi y dy. You can check it for 1 by n del m del y minus del n del x. If it is a function of x alone, that is for rule 2, e to the power integration fx dx is an integrating factor. Okay, let's move to rule 4. That is very important rule. It's very useful, very important. I'm putting a star marks here. And the rule is, if mx minus ny not equal to 0, then 1 by mx minus ny is an integrating factor of the equation m dx plus n dy equal to 0, where m and n can be written as in this form. Look at the form here. M is y into function of xy, n is x into function of xy. In this form, you have to check, you have to identify from the question that whether the function m and n are in the form of xy into y, x into fxy. So this is the functional form. Okay, and there is a note of that. We can reduce our calculation by this note. This is very important to note that m dx plus n dy can be written as half mx plus ny into dx by x plus dy by y plus mx minus ny into dx by x minus dy by y. If you open the bracket, you can get m dx plus n dy. So this can be written as like this. You can check that. You can, if you expand, if you open the bracket and expand, you will get this m dx plus n dy. Look at that. Mx into dx by x, x cancel, m dx, ny into dy by y, y cancel, n dy, and you have a similarly here also. If you expand, some terms will be get cancelled, and you have twice of mx m dx plus n dy, and you have a half outside. So you can write this equation in this form. Now if you multiply this m dx plus n dy by mx minus ny, then your first term will be mx plus ny by mx minus ny, and this will be d of log xy, because this is, if you integrate this, this is log x, this is log y. So this is d of log xy, and this will be d of log x by y. Okay, so you can write this in this form. You can write this in this form. So let us have some application on rule 4. I will give you 2 applications on that. First, let us have a problem on that. Y into 1 plus xy dx. Look at that. Your m is written in the form of y into function of xy. Okay, and look at that. Your n is written in the form x into f2 function of xy. Look at that. It is written in this form. Okay. Now let us calculate mx minus ny. What is your mx minus ny? So mx, that will be xy, and inside bracket I am taking common xy from both, because if you apply x, multiply x with m and y with n, so it will be xy also. So 1 plus xy plus 1 minus xy. Oh sorry, I am doing the my subtraction. So it will be minus 1 plus xy, right? So 1 get cancelled, and you have 2x square y square. Okay, so you have 2x square y square, and which is not equal to 0 for xy not equal to 0. If xy is not equal to 0, this should not be 0. This should not be 0. So you are I am writing this once again. I am writing this equation. So your equation is, what is your equation? Let me write this. M dx plus n dy by mx minus ny equal to, you can write half xy, because your term is mx m dx plus ny. So you look at that, you have written mx plus ny. You look at that, this is your mx plus ny. So mx plus ny is xy into 1 plus xy plus xy into 1 minus xy In the numerator I have mx plus ny. You look at that. In the numerator I have mx plus ny. Look at that. I am circling that. Mx plus ny. So your m is y into 1 plus xy and n is x into. So it will be xy into 1 plus xy, and it will be the next term will be xy into 1 minus xy by mx minus ny. That will be 2x square y square, right? 2x square y square, and you have d log of xy. So you can write d log xy plus one additional term here, d log of xy, d log of x by y. So d log of x by y. So that is the thing. So you simplify this, half xy, 1 xy get cancelled from the numerator and denominator, and if you open the bracket, so let me show you another step for your convenience. So 2xy, okay, look at that, 1 xy get cancelled from the numerator and denominator, and you have the same term, d log of xy plus d of log x by y, okay, d log of x by y, and it's complete. And if you reduce, this will be get cancelled, xy. So you have half 1 by xy d of log xy plus d of log x by y. This is the result. Now we can integrate this. Let's add a page here. I need a space to calculate. This is the last result. So you can write, this is as half. So I am writing mdx plus ndy plus mx by mx minus ny equal to 0. So this is equal to, this is equal to half 1 by xy, and d of log xy is 1 by xy d of xy, right? And d of log of xy, let it be log of x by y equal to 0. This is the equation. This is the simplified form, because I simplified this form. I simplified this result. Look at that. I simplified this result first. So that is the 3 steps or 4 steps is required to calculate that, and this is equal to 0. And this after integration, this will reduce into integrating dx by 1 by xy square, dz by z square, that will be minus half xy if you integrate, plus log of x by y equal to c. That is your answer. Okay, this is your answer. Clear? So this is how you will apply the problem. Let's have another problem. Or if you don't want to use this method, you can go directly apply this 1 by x square y square as an integrating factor, multiplying 1 by x square y square 2x square y square, and pair the solution, and you will get the answer. Let's apply another problem. Let me show you another one for your simplicity. So this is your m. M is given by your m is, let me show you the m. Your m is x y into, you look at that, here you have a y, x square y square plus xy plus 1, okay, and n is equal to, here you have a minus also, so minus x into x square y square minus xy plus 1, okay. So this is your, and look at that, it is of the form of, m is the form of y into function of xy. This is your observation. And how will you identify the problem? In this way you have to identify the problem. X into f2xy. This type of problems will be always like this. So in that case you will understand that this is of rule 4. You have to apply rule 4 in this. So again you apply, you first calculate mx minus ny first. So xy common, and you will get mx minus ny is x square y square plus xy plus 1 minus plus x square y square minus xy plus 1. So that this get cancelled xy. So you have xy 2xy into x square y square plus 1, and this is not equal to 0 if xy not equal to 0. So your integrating factor is 1 by mx minus ny. Let's again reduce that by using this mdx plus ndy. This is very helpful, very helpful. During exams this is very helpful. This will reduce your calculation, reduce your time, everything. And you write mx plus ny, you apply that. I'm writing that once again for your so that you can learn that thing. Mx minus ny, and the first thing is d of log xy, and the next term is d of log of x by y, right? Okay, so this is the thing. Now if you apply mx plus ny, and you can do the problem. Mx plus ny, you write, you calculate. Let me show you how. So your numerator will be xy into x square plus y square plus xy plus 1. So x square y square plus xy plus 1 plus xy into there is a minus, so n is minus, so it will be minus x square y square plus xy and minus 1, and denominator already you got the result here. Mx minus ny is 2xy into x square plus y square, x square y square plus 1 into d of, into, there is no space actually, log of xy plus another term you have d of log of x by y. Okay, so this is the term. And if you calculate, if you open the bracket, you look at that some terms will be get cancelled, x square y square. If you take xy common from the numerator, and x square y square and 1 plus 1 minus 1 get cancelled. So in the numerator you have only xy, and this xy get cancelled, and 2 is also get cancelled. So your reduced equation is, let me write the reduced equation, xy by x square y square plus 1 into d of xy by xy. What I am writing? I am writing d of log xy as dxy by xy, right? And this one is d of log of x by y. Okay, got it? That makes sense if you write d log of xy by dxy by xy. So again you see it is more reduced form, that is dxy by x square y square plus 1 plus d of log. So look at that. Initially the problem was in a complicated form. This is quite complicated form it was, but it is reduced in such a simple form in 3 steps. So this is very useful. Now if you integrate, that is equal to 0. So you will get, this is tan inverse, right? So this is tan inverse, first term is tan inverse xy plus log of x by y equal to c. So this is the general solution. So I solved 2 problems, 2 applications of this rule 4 I was talking about. This is very important, especially I am using this note. You can do it in a different way, like just simple multiplication with that integrating factor and pair up, you can do that, no problem. But if you use this note, the under mentioned note of simplifying the result, it will be more easier for you to solve. Next, today's last rule, that is the most complicated rule in our differential equation, that is rule 5. And the equation you have to form the equation in the form of this: x to the power alpha y to, your equation will be of this type. You have to identify, this is most complicated form, because you see your equation must be of the form x to the power alpha y to the power beta and my dx and plus nx dy, and after that x to the power alpha 1 y to the power beta 1 m1 y dx plus n1 x dy. So look at that, you have an unknown problem. First you will apply exactness. If it is exact, fantastic, no problem in that in solution. If you failed in exactness, you will test for rule 1, you will test for homogeneity, you will test for rule 2, you will test for rule 3, you will test for rule 4. Rule 4, so you will easily identify the problem type is a different type. Next, that is the last choice. Your last choice is rule 5, and there are problem on rule 5. There are problems on rule 5, and this is the most complicated form. You look at that the form, there are so many things: alpha, beta, m, n, alpha 1, beta 1, m1, n1. So these are all constants, and this is the condition where you can apply m n1 minus m1n should not be 0. You can check that, please check that before you apply, has an integrating factor of the type x to the power h, y to the power k, where h and k are constants given by these two simultaneous equations. These are the two simultaneous equations. Okay, so let us apply the problem now. So this is the problem. You will check for del m del y del n del x. So it is not exact, I am not checking that, you can check that. So if you have failed for exactness, you will go for rule 1. If you failed in rule 1, go to rule 2, rule 3, rule 4. This is not in rule 4 form, this is not in the form of that, but you can write that equation in the form of x square into 2y dx plus, you open the bracket and write the equation in this form, 3x dy plus y cube minus 3y dx plus 2x dy equal to 0. This is rule 5. So you look at that, it is of the form of this: x to the power alpha, y to the power beta. There is no y in the first term, so y to the power is 0. That is why you are getting 1 here. Here there is no x here, so x to the power 0. That is why you are getting 1 here. So you can compare with this equation. You can write the values of alpha, beta, alpha 1, beta 1, m, n, m1, n1. Let me write. What is your alpha? Alpha is x to the power, so 2. What is your beta? Beta is y to the power. There is no y, so it is 0. What is your m? M is 2. Look at that. It is written my dx. So you have my dx. M is 2. What is your n? N is 3 because you have nx dy. Okay. And what is your m1? Oh, alpha 1. Sorry. Alpha 1 is 0 here because there is no x. There is no x. And what is your beta 1? Beta 1 is 3. And what is your m1? M1 is minus 3. Look at that, your m1 minus 3. And what is your n1? N1 is 2. This is 2. So these are the values. Okay. And you can check this condition. mn1, what is your mn1? 2 into 2, 4, and 3 into minus 3, minus 9. And that is, if you take 9 plus 4, 13, not equal to 0. That is not equal to 0. So mn1 minus m1n. m1n not equal to 0. Right? This is not equal to 0. this is not equal to 0. So you can apply, what is your condition? H plus 1 plus alpha by m, k plus 1 plus beta by n. Hk, you have to find out hk from these linear equations. What is your h and what is your k? H and k are unknown. H and k are unknown. So let us substitute. If you substitute h plus 1 plus alpha by m equal to k plus 1 plus beta by n, okay, and that is equal to, if you substitute all this, that will give you the linear simultaneous equation. So I am not calculating the whole. You will get, this is equation 1. And in the second condition, if you put in the second condition, h plus 1 plus alpha 1 by m1 equal to k plus 1 plus beta 1 by n1, that is equal to 2h plus 3k plus 14 equal to 0. This is equation 2. Okay, this is very simple. Just you have to identify, you have to write the equation in the form, in this form, otherwise you can't do that. And finally you have to substitute and get the simultaneous equation. Solve. If you solve, you will get the values of h, as that is more complicated value. I have solved and I am giving you the result. H will be minus 49 by 13. You can check that, and k will be minus 28 by 13. So your integrating factor will be, what is the integrating factor? Your integrating factor will be x to the power minus 49 by 13, x to the power h, y to the power k, and minus 28 by 13. You multiply the whole equation with this, that is more complicated form, and the equation can be written like this. I am just writing the equation: minus d 13 by 5 x to the power minus, I have calculated actually. You try this. This is a tough problem for you because this calculation is a very difficult one. And 13 by 12. After getting the value of h and k, you can easily pair the things. That will be easier for you. But before that, you have to be careful how to write the equation. So this is the, and you know, if you integrate this, you will get the solution. So for my dear students, I am giving you one more problem with this applying. I'm just giving you as an assignment, applying this rule 5. You have to apply rule 5. This is applicable for rule 5 only. So example I am giving to you, all of you: y square, sorry, let me write y square plus 2x square y into dx plus 2x cube minus xy into dy equal to 0. You can try that. I am just giving you also the hint also. X to the power minus half, y to the power 3 by 2 is an integrating factor. You try this. This is very helpful. So today I stop here. So today my lecture was focusing on how to calculate how to use the rules for integrating factors, different rules of integrating factors, and how to apply mainly the applications of different integrating factors in the problems, how to identify the problems, how to write the problem in a form that you can use the integrating factor. Okay, dear students, so follow my videos and follow my lectures. Thank you all.